Thanks, everybody. So welcome. Thanks for having me. So yeah, I was going to talk a little bit about building Lambda functions or AWS Lambda functions using Python. Actually, I'm going to start my timer here because otherwise I will go over time, and we're already pressed for time. So setting the stage. Imagine you've written a nice little command line app in Python, of course, that generates a little HTML file. And you want to take that HTML file and put it on the web so somebody can go www.whatever your website is and see that content. And that content is dynamic, like it changes every time the page is generated. So normally the way you do that is you'd like pull out your favorite web framework, like Django, Flask, whatever, and you'd provision a server, configure the server, install security patches, all this infrastructure stuff that, I don't know, me as a developer, I don't want to do. But you've heard about this cool thing called AWS Lambda and serverless functions and how you don't have to worry about any of that stuff. And how that's taking over the world. And you also heard that there's frameworks for making working with Lambdas easier, but you know what? You're a glutton for punishment. You're not going to do things the easy way. You want to learn everything. And so you're going to reinvent the wheel. So let's do that. So I'm going to show you how to use AWS Lambda, which is one of this serverless function offerings, for serving up some basic HTML. So just general overview, I'm going to talk a little bit about what serverless computing is and functions as a service. Sorry,
could you increase the font size a little bit?
Absolutely. Is that better?
Yeah.
Is that too big? Bigger? Good?
Okay. Yeah, but then it doesn't like show the whole screen. Scroll.
Okay. Is that okay?
Yeah.
Cool.
Sorry. Thank you.
No worries. So then I'm going to, because this is a Python meetup, I'm going to tell you how Python relates to all this stuff. I'm going to show you a little example of how do you make your Lambda function actually accessible via the web, like i.e. somebody can go HTTP blah, blah, blah in a web browser and actually hit your Lambda function. And that's going to involve another AWS service. And then I'm going to talk a little bit how you might unit test your Lambda function. And then I'm going to talk about how you get Python packages working in your Lambda function, like maybe like you want to use Jinja for generating the HTML output or something. I'm going to talk a little bit about a gotcha related to that. And then I'm going to, because I went through this whole exercise, I'm going to talk about, time permitting, a little bit about the two frameworks I know about for working with Lambdas that make it easier. But the goal here is to just give you a sense of how to use Python to create an AWS Lambda function that returns some dynamic HTML. Cool? Bye. Please, feel free to stop me at any time. Yes?
Do you have a Git repository?
I do, and that's this, the link there at the bottom, the bit.ly, so bit.ly/2s5wibc. Alternatively, if you go to my GitHub account, the repo's in there, or come talk to me afterwards and I'll happily give it to you. Thank you for bringing that up because I was going to mention that. So yeah, all the slides, all the code I'm going to show you is in that repo. But yes, please make this interactive. Stop me at any time, ask me questions, because I like to have conversations. I just want to sit here and blab at you for a while. But for now, I'll just blab at you for a little while until the first questions come. So what is serverless computing? So all the big cloud providers, be it Azure or Google or AWS, have this offering that's some people call functions as a service. The idea is you take a little bit of code you've written, a function, and they will provision all the infrastructure for you. And you just throw your code on there and it just works. And you don't have to think about the server, which is nice, because I just want to write code. I don't want to think about servers. So AWS's offering is called Lambda. And it's useful largely because you don't have to think about provisioning servers or installing security updates or any of all that stuff. It's also very, very cheap, especially for low use scenarios. So you think about it, like normally you provision a server, you're going to pay for that server as long as it's running, regardless of it's actually being used or not. Whereas Lambda is very much the sort of utility, pay-as-you-go, pay-as-you-use model. And that 1 million calls for free a month is a bit misleading. There's a few more factors that go into it, like how long your function runs for, how much memory it uses, but ballpark, about 1 million calls per month for free. And I like free. It's also infinitely scalable. The reason for that is the way Lambda works and the way all these serverless function providers work is what they do is they take your code and they throw it in a Docker image. And then they put that Docker image on some hardware that they provision. And so when somebody actually triggers your function, it spins up the container, runs the the function returns the result. If 10 people hit it all at once, it spins up 10 containers. If 1,000,000 people hit it at once, it spins up 1,000,000 containers in parallel. So you can see it scales horizontally very, very, very nicely. Obviously, depending on what your Lambda function does, and if there's like some sort of central resource that they all hit, like a database, that is still going to be a bottleneck, but at least conceptually, it's infinitely scalable. And it can be used for a lot of sort of, yes?
Oh, so whenever a new client hits the endpoint, then a new container is popped up, they don't share containers?
I don't think so.
Because it seems kind of like expensive to...
It's AWS's problem, right? Like they handle all that for you, right?
No, I thought you knew how it worked behind the scenes.
No, I don't work for AWS, so I can sort of theorize, but conceptually, it's. I do know that it like spins up a container. It runs your code in a container.
Okay.
But yeah, good question. So it can be very good for like data processing tasks. Imagine you want to take a video and transcode it to a bunch of different formats. Every time a video is uploaded to S3 bucket, you can have a Lambda that runs every time a file is uploaded, etc. Various other tasks. I don't want to spend a ton of time on this because this is a Python meetup. We're going to do something that's kind of like a REST API, but moving right along in the interest of time. So why does it suck? Why is it not so good? One of the reasons is it's kind of a different way of sort of thinking about solving your problem. You're thinking in terms more in terms of functions than sort of like an application as a whole. And there's also that start performance, and that kind of relates to the thing you were bringing up. Like spinning up a container just to run a little function seems like a lot of overhead. So if your function isn't being hit very often, there's a sort of initial startup time that you're going to pay. Or so I've heard. I haven't really run into that myself, but questions so far? Cool. And I saw this image. I thought it was hilarious, so I had to throw it in. Yeah. Anyway. So anyways, okay, so this is a Python meetup, not an AWS one, so where does Python fit in? So these Lambda functions you can write in a number of different languages. AWS Lambda supports JavaScript, Go, Python. I think I heard they're adding C++ support soon, which blows my mind. And Python's been one of the languages that's been supported for as long as I've known about AWS Lambda, which is around 2015-ish that I heard about it. One of the downsides, though, for AWS is some of the docs are a little weak for Python examples. When you see the little code snippets, they're usually written in JavaScript. And as a Pythonista, that kind of makes me sad. But it's usually pretty straightforward and trivial to take example written in JavaScript and write the equivalent Python. And hopefully after what you see tonight, you'll have a really good idea of how that would work. So how do you do this? Well, you create your function, a plain old Python function. You run it, or rather AWS runs it, and then you profit. So that's kind of the high level idea. But really, it is pretty simple. So let's actually do an example of creating one. So I'll zoom in a bit here. Is that good, or should I zoom in more? A little more? Cool. Oh, that is big. Okay, so I'm just signed into the AWS Management Console. This is my personal account. And if I search for Lambda, you can see it's running code without even thinking about the servers. You don't even have to think about them. That's a bold claim. Anyways, so if I pick Lambda, I don't see anything. Oh, that's about as far as I can zoom in. So you can see I already have a function that I created before for a little pet project I was working on, but I'm going to step through creating a new one. So if you click create function, you get these sort of three choices. You can author completely from scratch, starting from nothing. I'm not that much of a glutton for punishment, so I'm going to go with the blueprints. And then, so the blueprints are sort of these pre-made examples that AWS gives you. I'm going to search for the hello world one, because you always start with hello world. You'll notice that there's versions for Node, a version for Python 2.7, legacy Python, or there's 3.6. I like the new shiny. I like f-strings. F-strings are amazing. So I'll pick 3.6. And so the first thing you get presented with, what do you want to name your function? So yeah, what do I want to name my function? Help me out here. Sorry? PyCascades. Ooh, that's a good one. By the way, go to PyCascades. It's awesome. Thanks. So first thing you're presented with is like you have to choose an existing IAM role. IAM stands for Identity and Access Management. It's an AWS thing. Basically, it's the permissions that govern your Lambda function. Because I don't want to get too deep into this, I'm just going to create a new role from one or more templates. You have to give your role a name, so I'm going to call it the same thing as my function. This is sort of first time boilerplate setup stuff. Bear with me. I'm not going to add any policy templates. Those are used for adding permissions for other AWS services, which we won't need for this example. And then here's the sample code that they give you, which is just a simple little function. You can see it takes two arguments, an event and a context. So the event is basically a dictionary that encompasses all the arguments to your function. It's like a key, just a key mapping pair. And the context gives you some information about the environment your Lambda function is running in. Like, when was it started? How much memory does it have allocated to it? Stuff like that. I've actually never used the context argument myself. I've never had a need to. But you can see this simple example. All it's doing is going to print out the value, 3 of the values from the event dictionary that's passed in, and then return one of the values back. Really kind of simple function. So if I create, and hopefully the demo gods will smile at me, and this won't take forever. Won't take forever. Will not take forever. Okay, there we go. Okay, so as is the case with a lot of stuff in AWS, unfortunately, the UI tends to be a bit overwhelming. There's a lot of buttons and knobs and dials to tweak. The one I want to just draw attention to is this basic settings one here. You'll notice there's this dial for memory, and that's how much memory you can allocate to your function. And I can go, all the way up to 3 gigs. Holy cow, that's awesome. I can just use tons of memory. Why do you not want to do that? Exactly, cost. So the way you pay for Lambda is it's based on how long your function runs for and how much memory it uses. So more memory means more money. So yes, I'm just going to go with 128 megs. And this timeout value is how long Lambda will let your function run for before it just kills it. So if your function takes longer than 3 seconds, it doesn't matter. Lambda's just going to kill it. And that's to save a situation for, if you accidentally put in like an infinite loop, and otherwise you end up with an infinitely large bill. But anyways, I just wanted to draw attention to that one. In terms of running the Lambda function, we can do it here in the UI with this test button. And you can create what's called a test event, which is just, this is the dictionary that will get passed in as that event argument. Unfortunately, you have to give a name to this test event. I'm going to call it test because I can't think of a better name. Once you do that, you can then click the test button with the test event, and it will run it. And you can see the execution was successful, and I can click on details. I can see the output. So there's those 3 print statements. The stuff above it and below is just AWS debugging information that's spitting out at you. And then the value it's returning. So it's just pulling one of those values out of the dictionary and returning it. That was what our code did. Does that make sense? Pretty straightforward, right? Now this is running on a server somewhere. I didn't provision a server. I didn't install any patches. I didn't do any of that stuff. AWS took care of that for me. That's kind of sweet. I do like that. But I said we were going to get to the point where user could type in www or some URL in their web browser and see HTML content. So let's come up with a little bit more interesting example. So one of the things you can do is you can actually edit the code here in the web browser. You're not going to do that. You're probably going to use your favorite editor. I happen to like VS Code. So I'm going to open up an example here. So here's a simple little function that just returns some HTML, and it's dynamic. It's dynamic because it uses f strings, and it just spits in the current time into that string. So really simple code, right? Just some HTML with the current date and time plunked into it. And then just as a nicety, I actually also made this a script I can run via the command line. Like I could open up a terminal and type, what do they call this file? foobar.py. I could type /foobar.py and would run it, and I would see the output, the same output that Lambda will do. But the question kind of comes, how do I get this code here in my editor into Lambda? And the answer is, first we'll close that. I'll go into the directory. All you do is you zip it all up. Sorry, that's not very big. So you just take your code, you zip it into a zip file. Once you've done that, go back to the console here. You'll notice there's an option here for uploading a zip file. You give it the zip file like so. and hit save. And then what that'll do is I'll upload that zip file to AWS. AWS will take it, it'll unzip it, take all the contents, throw it into a Docker image that it can then like run on some server somewhere. I got an error message. The reason I got an error message is because this name of the file does not match this handler thing here. So the file that AWS originally created was called Lambda function. I can change it to foobar. So this handler thing is just the entry point to your function. Unfortunately, if you do change the name, you have to re-upload the zip file, which makes no sense to me at all. I don't know why, but once I do that, I should see my code. Cool, there it is. And then I can test it out again, and you can see, ooh, hey, there's my output. And look, there's the current time. It looks like this is running in UTC, so it's probably the local time on the server that it actually happens to be running on. But it's dynamic contact. Like each time I run this, the time is going to change, right? Cool?
Yeah,
Cool. So let's continue on. Oh yeah, that was what I was going to do. So that's cool, but like this is not user going to browser, typing in URL, seeing HTML. So unfortunately, to make that happen, we have to use another AWS service. This is the thing about AWS is once you use one service, you have to start using another service, and then you have to start using another service. And that other service is called API Gateway. So I'm going to open up API Gateway in another tab here. And I would recommend opening a separate tab because you'll find you'll be going back and forth between these two things a lot. You can see I've already created an API previously for a pet project, but I'm going to create a new one here for my new Lambda function. I'm just going to collapse that down. I'm going to create a new API. I can call it whatever I want, just for consistency's sake. And because I can't think of a good name. Actually, no, not foobar, sorry. PyCascades. Nice subliminal messaging. Go to PyCascades, go to PyCascades. And then this endpoint type, it has to do with if you pick edge optimized, it'll be a little bit faster because it'll actually use a service called CloudFront for distributing the content all across the world. That incurs an extra cost, so I'm not going to pick that. And private is like internal use only, so I obviously don't want that. I want something public. So I'm just going to go with the default of regional.
So does this setup cost money?
The API gateway?
Yeah.
Yes, it does.
Okay.
I believe it's $3.50 for the first million calls, or I can't remember. It's
Okay.
like the lowest price is $3.50 for a good number of calls.
So serverless isn't free because.
Well, yeah,
it's-
that's the thing, right?
Yeah.
And like, if you really get into Lambda, you'll probably discover other services you want to integrate with, and like
Yeah.
that's how AWS makes its money, right?
Gotcha.
It's a slippery slope. But anyways, okay, so you can see there's this actions dialog here, and I can create new resources. This is API Gateway is really geared towards creating REST APIs. I'm just going to create a new method off of the top level root, and I'm going to pick an HTTP GET. So you can see these are the different HTTP verbs. So the idea is whenever the user does an HTTP GET on the top level root, it's going to call my Lambda function. Well, whoa, look at this. The first integration type is Lambda function. It's like they built it to work with Lambda or something. Crazy that, eh? So one thing I'm just going to like file this away as a just follow my lead and do as I say. I would recommend taking off this use Lambda proxy integration, and I'll explain why that's useful in a second. But for now, just do it. And then you can pick the Lambda function you want to actually trigger. In this case, I'm going to pick my PyCascades Lambda, hit save, and you get this dialog that pops up. And this is kind of nice, because in ye old days of API Gateway, you actually had to manually set up permissions between API Gateway and Lambda to tell AWS that, yes, my API Gateway can talk to my Lambda function. It has permission to do so. Whereas now when I just click OK on this, it's going to set all that up for me, which is nice. A little bit convenient. Once you do that, you get this sort of visualization of the flow. Request comes in, goes to a Lambda. Well, which Lambda? Well, my PyCascades Lambda. The response comes back from here. And you notice this thing is grayed out. That was that little tick box I said that you should tick. If you don't tick that, then you have to essentially define these rules on how to transform the thing that it gets back from Lambda into something it can actually send back on the wire as an HTTP response. Whereas if you do that, tick that little box, it just does it for you, which is kind of nice. and then the response back to the client. And we can test this out by clicking the test button. And if I click test, everything will be, oh, there we go. Oh, that's not good. Internal server error. Uh-oh, what did I do? Execution failed due to configuration error. Malformed Lambda proxy response. So the downside to ticking that little tick box is the response from your Lambda has to have a certain form. It actually has to be a dictionary that looks like version 2. So essentially, it's a dictionary that has a value called status code, and that's the HTTP status code that you want to return. In this case, I'm returning 200 OK. You can set any response headers you want in the form of another dictionary. In this case, I'm just saying the content type of text HTML, and then the body, which is the actual content of your response. In this case, my raw HTML I've generated. Okay, so I can version 2. Zip it up, go back to UI, and you can see already this is getting a little tedious, this whole like zip a file, go to the UI, pick upload, go upload, find the file. This is kind of annoying. And once I hit save, you'll notice there is actually a third option on that dropdown that's upload a file from Amazon S3. And if you really get into using Lambda, you'll probably start taking advantage of that. What it allows you to do is essentially, you could build out like an automated pipeline that when it zips the file, it just automatically uploads it to an S3 bucket and then tells Lambda, hey, go look in that S3 bucket and deploy that. I'm not going to do that tonight, but just to give you an idea that it doesn't have to be this tedious. So once I do that, if I hit test, I should see, oh, there's my dictionary response as I expected with the content. Cool, that's nice. So if I go back to API gateway here and hit test, no more server error. That's nice. Response code 200 as I expected. There's my HTML content. Beauty. Cool. I think we're good to go. So now what we can do is we can click the nice deploy button. So under that drop down there, there's a deploy API. And the first time you do this, you have to actually set up what's called a stage. You can think of stage as being like an environment. Like you might have an environment for production and a different environment for, say, testing or staging. I'm not going to go through how to set all that up, but that's sort of the idea of what stages are for. But once you deploy it, there's a URL. And if I open that URL, whoa, sweet. So that URL is public. If any of you right now went to that URL, which unfortunately is very long, you would see this page. And each time I refresh it, the content changes. A nice little dynamic web app, right?
Nice.
Yeah. And I didn't provision a server. I didn't install any security updates. None of that stuff. Just wrote the code. So pretty simple, right? Sort of.
Really not right.
Well, it's UTC time, so you could change the code to make it localized to the user.
So you just charge $3 right now for setting up the API?
See, that's the thing is I don't think I was, because when I was preparing for this talk, I set one up and then tore it down. I did that last month, and my bill this month, there was no charge for API gateway. But the pricing page says I should have been. So I don't know what happened, but I'm not going to ask questions. But presumably, maybe? Or maybe it's only after a certain number of calls that you actually get billed or something. I don't know. I'll let you know what my bill looks like next month. Cool. Questions?
Maybe you should publish the link so we can hit it.
Maybe not.
You're the bot.
Yeah, I'm going to tear this gateway down tonight. It is worth noting you can set up a custom domain with API gateway. It doesn't have to be that ugly URL that Amazon gives you. Yeah?
Do you have dependencies in your code?
Yes, you can. And that's a great segue. I don't think that's my next slide, but I think that's in a couple slides. So I will get to that. Cool. Other questions?
Do you know if there's an integration with GitHub so it can pull from a GitHub repository?
I don't think so, but that would be cool. Yeah. I am really pressed for time here, so I'm going to kind of go quickly. Just a note on testing. So who knows who this guy is? Does Does anybody know who this guy is? Who is it? It's Uncle Bob Martin. So he is he wrote a book called Clean Code. It's a really good book. You should all read it. And he talks a lot about this thing called the single responsibility principle, which is this idea that a chunk of code should have or at most one reason to change, or at least that's the ideal you should strive towards. So right now my Lambda function kind of violates that. Like if the format that AWS supplies, this function is going to change. If I want to change the HTML output, this function is going to change. If there's a million reasons why this function would change. So I would really recommend, if you get going with Lambda, break apart the function that actually interfaces with Lambda versus your Python code that you would normally run just completely independent of Lambda. And then you can unit test those completely independently. And I won't open up in the interest of time, but I do have an example of showing some sample code of doing that, just breaking it up. So that's the single responsibility principle. Cool? Cool. So coming back to your question about dependencies. How do pip install? I don't have a server anymore. So how do I get my dependencies? Because you know what? Like this worked, but writing raw HTML in your Python code is madness. Especially when you have tools like things like Jinja. So how do you get the Jinja onto your Lambda function? And the answer is you just give a little extra argument to pip. So you do your pip install -r requirements, and then you add a -t dot. And what that does is installs the dependencies into the current directory you're in. And then when you zip your code up, you zip the dependencies up with your code and upload that whole big blob to Lambda. Does that make sense? Cool. So there's a copy of the code in the repository that shows this. It uses Jinja to actually break out the whole, generating the HTML stuff.
By the way, would this work with anything that is dependent on OS?
Oh man, you're reading my mind. That's my next slide. So imagine you have a dependency like that, like LXML. So LXML is XML parser, and it has some system level dependencies, i.e. like platform-specific dependencies that it's based upon. Now, when you do the pip install on your local machine, like if I did it right here on this machine, that would be built for a Mac, not for what Lambda is using. So if you try that and you upload your zip file and you try running it, you're going to get an error message. The error message will vary depending what the library is, but it'll error. So this kind of just summarizes that. The image that AWS builds for you is targeted to a specific platform. So if you want one of those, how do XML? That's my terrible Scooby-Doo impression. So if you want to do that, what do? Well, the answer is you Docker all the things. That is, you build your dependencies inside a Docker container that matches the Docker image that AWS is using. And so I have a Docker file that shows exactly how to do that. So the key bit is just to use Amazon Linux as your base image. Once you do that, you just install pip, zip, Python, you copy your source files over, you do the pip install line to install the dependencies, and then at the end you just zip it all up into a zip file, and then you just got to get that zip file to Amazon. So you could extend this a bit to add some code for, say, uploading that zip file to an S3 bucket, or I don't know, copying it to a network share somewhere or something like that. Or if you just want to do this locally, you do something like this. So you build your Docker image. That would build the whole thing up. It would create a zip file inside the Docker image of the thing you need to give to AWS. If you want to get that zip file out, just run a Docker container mounting a directory on your host machine to that directory inside the container, and then copy the zip file out. And then you'll have the zip file on your machine that you could then upload to AWS. Does that make sense?
So the Docker image is inside the zip file?
No, the zip file is inside the Docker image.
Zip files inside.
Yeah.
Yeah.
But what's in the zip file? The dependencies?
Yeah, it would be the exact same thing as if I had built it on my local machine, just with the system dependencies for that Lambda wants.
How does it go into Lambda?
How do you get the zip file to Lambda?
Yeah.
Well, you do it the same way. You somehow got to get that zip file out of the Docker image, and that's what this highlighted line here is for. And then you could just manually go into the console, upload the zip file. Actually, why don't I just do that? Because I have a sample. So final version here, version 5. Where's my terminal? Version 5. Then I gotta build it. Maybe I won't do that. I won't tempt the demo gods on that one. So take my word for it if you try this, or actually don't take my word for it. Take my slides, try it out. If it doesn't work, email me, let me know, and I'll help you out. Does that make sense though? At least the concept? Cool. That was a huge gotcha for me with Lambda. And we are pretty much at time here. So just one quick little note. I said I was reinventing the wheel because I said there's frameworks for making working with Lambda easier. So why did I do that? And I think the reason is, for me, it's sometimes a really great way to learn. And I saw this tweet that really resonated with me when I was preparing for this. And I find reinventing the wheel is an awesome way to learn. Sometimes what you learn is just how much your frameworks are doing for you. And I've definitely got a feel for that working on or preparing this talk. Even though in the future I'll probably start using some of those frameworks, when things go sideways, I'll have a bit of an idea of what's going on behind the scenes. So I'll have a better, I'll have more knowledge to bring to the forefront in debugging. Last slide, just there's 2 frameworks that I know about that are help working with Lambda, make working with Lambda easier. One is called serverless. It's the one that seems to be the most popular. It's kind of nodey, if that's a word. You can certainly write Python lambdas with it, but all the examples seem like it's a node package itself. So it feels kind of node orientated. So I mean, if you're cool with that, then cool, but I haven't really played with serverless very much. And the other one that is more Python specific is called Zappa. And what it does is it takes your WSGI app, like your Django app, your Flask app, and somehow makes that work in Lambda. I have no idea how that happens, but that sounds really cool. So I want to play with that.
There's another one from AWS that's called Chalice or something like that.
I don't know that one.
Chalica. Like it's Flask, but it has the same API as Flask, but turns each of the endpoints to an Lambda or something.
Cool.
I didn't try.
I'm gonna look into that. That's cool. Thank you. And then the last thing is, if you're more the sort of ops-oriented type and you want to play with all the dials in AWS, using infrastructure as code tools like CloudFormation or Terraform are also very useful for setting up Lambda functions. I haven't really played with those a whole lot myself because I'm more of a dev than an ops person, but I know people who have. Anyways, that's it. I'm way past time. Sorry about that. Thank you very much.
Setting up the API.
See, that's the thing is I don't think I was, because when I was
Setting up the API.
See, that's the thing is I don't think I was, because when I was
Setting up the API.
See, that's the thing is I don't think I was, because when I was
Setting up the API.
See, that's the thing is I don't think I was, because when I was
Setting up the API.
See, that's the thing is I don't think I was, because when I was